Okay, we've got this differential equation. It's a differential equation because it's got a dy by dx in it. So when I've solved it, I'm going to have y equals something, and I need to get the solution into that form. So I've got to untangle this. So I've got x dy by dx, okay, equals y plus 3. So what I'm going to do is I'm going to pretend that dy and x and dy and dx are numbers. They aren't, but I can do that pretense. So x dy by dx equals, so I'm multiplying by dx, so I'm going to say it's y plus 3 dx. So I can only rearrange by multiplying and dividing. I can't get rid of that y, for example, by subtracting it. So what's wrong with this is I've got all the y's on one side and all the x's on the other side. So I have to divide by the x, and I also have to divide by the y plus 3. So I'm going to end up with a dy here and a dx here. Now I'm dividing by the y plus 3, so I'm going to put over y plus 3 here. I don't want to do dy divided by y plus 3 because it's uglier. And I'm also going to divide by this x, so I'm going to get an over x here. And because I've divided by this, actually this is 1 over x. And because I've divided this by x, I've got 1 over y plus 3. So this is just dividing by the x and also dividing by the bracket of y plus 3. So now I have the integral of y plus 3 equals the integral of 1 over x, because these dy and dx don't really mean anything on their own. But if I put an integral in front of them, then this is mathematically correct again. So now I've got two integrals to do. Now this integral here is, well, this one is easy because differentiate x, you get 1. Or you might just spot this as being log of x. Okay, and this one, similarly, if you differentiate, this has got y as the letter, but it's still the same kind of idea. If I differentiate y plus 3, I get 1. So this is a log as well. This is log of y plus 3. So I recognise my log rule for integration. Notice I haven't bothered with any stupid modulus signs, because normally they do more harm than good. If I ever find myself doing log of something negative, then I'm going to go back and put in the modulus signs. Okay, now I've forgotten constants of integration. But if I put a constant of integration on both sides, I should call them something different. I should put, say, plus c1 here and plus c2 here. But if I take this plus c1 away, then I could combine it with a constant on this side. So I only need one constant of integration ever, and I always put it on the right hand side. So now I've got a solution of the equation. I've got rid of the differentiation, I've got y and x in my equation, but this one wants me to get down to y equals, so I've got to make the log go away. So I'm going to e it. So I'm going to have to work in columns. Oh no. So I'm going to say that eing this gets rid of the log, so I'm going to get y plus 3 equals e to the power of log x plus c. Now, it's tempting to say that I could do e to the ln x, which is nice, and e to the c separately, but I'm not allowed to add those together. Logs, there is no rule of logs that says you can e this separately from this. Okay, but what I can do is I can use the rule of powers, because I know that x to the power of p plus q equals x to the power of p times x to the power of q. Okay, so if I do that to here, you see, this is why I don't like working in columns, because I want some scribble space. If I do e to the power of ln x plus c, and I say, well, using rules of powers, that's e to the ln x times e to the c, then I can do two things. I can say e to the ln x, well, the e now does cancel the log, so that's going to become an x, and it's times, now c is just a constant, it's any old thing I could have added. So e to the c is a constant, and the tradition is we call it a different name, and that name happens to be capital A. So I've got a times x here. So my next line is that y plus 3 equals, I've done all the work here, this is a times x. So the additive constant plus c that I started with has turned into a multiplicative constant times a. So the next line after that is y equals ax, I want y on its own, so ax minus 3. Now, it says give a particular solution. Okay, so the first thing was the general solution. So so far I've been doing part 1, and this is my general solution. Okay, but the particular solution, which does this, okay, so now I want for part 2, I need to use the point 2, 3. So 2, 3, well, what's 2, 3 telling me? It's telling me an x value of 2 and a y value of 3. And I know that y equals ax plus 3, so now my mission is to find out what a is. So I'm going to substitute in the 2 and the 3, so 3, that's what y is, equals a times whatever x is, a times x is 2, minus 3. So I solved this for a, so I'm going to get 2a equals 6, so a equals 3. So my particular solution is going to be what I had before, but with the a replaced by 3. So particular solution equals y, well, particular solution is y equals 3x minus